Hello Math 1040 class. I hope your week is going well and you're working nicely through our statistics course. I've received a couple emails this week from students who have been working ahead, and I thought I should be able to offer some extra assistance with some of the questions they were asking. Let's take a look at the course calendar for a minute so I can show you what I'm talking about. This Thursday on the 26th, we should be looking at homework for sections 2.2 and 2.3, which specifically talk about hypothesis testing. And I kind of feel like the recorded lecture videos and the guided lecture notes missed a couple really good examples that I think would be helpful in looking at your homework. So I wanted to make a supplemental video and a little handout that you can use to help with these questions. I'm going to attach this handout with this video so that you can download it and look at it with me as you go through the video. So make sure you pause this video for a minute and print off this handout so you can work on this as we go through the video together. In this section, we want to know that hypothesis testing is an act in statistics where we test an assumption regarding a population parameter using sample data. Such data may come from a larger population or a data generating process. Now, in this section of our class, we will be using simulations to conduct our hypothesis tests. Now, we say data from these simulations will provide statistically significant evidence against the null hypothesis if the p-value is less than some threshold. Often it's taken to be 0.05, 0.01, or 0.10, but it can vary depending on the severity of making a type 1 error. Now, if our p-value is less than this level of significance, that's when we are going to reject the null hypothesis and say there is sufficient evidence to conclude the alternative hypothesis is true. Now, to help you with this, sometimes people use this short saying. If the p is low, the null must go. Because if your p-value is low, then it's going to be less than your level of significance. You'll reject the null hypothesis. The null must go, and that tells us there is sufficient evidence to conclude the alternative hypothesis is true. So that little saying might be helpful for you. Now, if your p-value is greater than your level of significance, then this is when we fail to reject the null hypothesis and say there is insufficient evidence to conclude the alternative hypothesis is true. And again, pay attention to the wording here. If you reject your null hypothesis, there is sufficient evidence. If you fail to reject your null hypothesis, then there's insufficient evidence to conclude the alternative hypothesis is true. Let's look at some examples though to help get you familiar with this idea. We are told 37% of Americans have a valid, unexpired passport. However, a researcher claims that the percentage of New York residents with a valid, unexpired passport is greater than 37%. In a random sample of 25 New York residents, 11 have a valid, unexpired passport. Use the results of the 100 simulations shown in the null distribution to examine the researcher's claim that the proportion is greater than 0.37. Now there's a lot going on here, so let's try and break this down into smaller pieces as I go through this hypothesis test. Based on the above description, the correct null and alternative hypotheses are as follows. Now remember, the null hypothesis, written as H naught, is going to be a statement about what the believed proportion is. And that is that 37% have a valid unexpired passport. Notice that it has an equal sign. The null hypothesis will always have an equal sign, and it will be equal to whatever the stated, known, or believed value of this proportion is. The alternative hypothesis. This is always going to be a statement about what the researcher believes. And we are told that the researcher thinks that the New York residence with a valid passport is greater than 0.37. And the greater than is what tells us that the inequality or the proportion is greater than 0.37. And the fact that it's greater than also tells us that we're looking at a right-tailed test. Now let's continue. P hat, this is your sample proportion. This came from your random sample, which we were told 11 out of the 25 random sampled New Yorks have a valid passport. That tells us that our P hat, our sample proportion, is that 1125 or 0.44. Now, the null distribution, the picture in this upper corner. This null distribution is always created based on the assumption that the null hypothesis is true. That is, it is created and simulated assuming that the true proportion equals 0.37. And notice that that is where the bell curve appears to be centered at. It appears to be centered at that 0.37 area. Now our p-value. The p-value can be found by counting the number of dots or the simulations in the null distribution that are beyond the sample value of 0.44, where beyond is interpreted as in support of the alternative hypothesis. And the ones that are in support of the alternative hypothesis are those that are greater than this. So what we will look at is the value of 0.44 or those simulations that are even more supportive of the alternative hypothesis. Now 0.44 is in support because it's definitely greater than 0.37, but any of these values that are beyond 0.44 also offer support to the alternative hypothesis. Notice that these are the simulations that are to the right of p hat, and that's why we're calling this the right-tailed test. So we'll count the number of dots, and I believe there are 24 dots or 24 of the simulations that are greater than 0.44. And so from this 24 simulations, and the fact that there are 100 simulations in total here, we calculate our p-value as 24 over 100 or 0.24. Now to finish off our hypothesis test, we will compare this p-value to some level of significance. Now it can vary, but the most common value is 0.05. Which means we will allow a 5% chance of making a type 1 error. Now here our p-value was 0.24, which is greater than our level of significance 0.05, which means we will fail to reject the null hypothesis. And remember, when we fail to reject, it means we have insufficient evidence that the percentage of New York residents with a valid unexpired passport is greater than 37%. there's insufficient evidence that it's greater than 37%. Now this is our first example, and a lot of it was written out for us so that we can kind of go through the steps and the terminology quickly. But let's look at another example together. Evie read an article that said 6% of teenagers were vegetarian, but she thinks it's higher for students at her school. Now, these two pieces here are trying to give us important information about the null and alternative hypothesis. The article, that's what's telling us the currently held belief. This is our null hypothesis. However, Evie thinks it's higher in her school. This is what she is going to try and find evidence to support. This is the alternative hypothesis. To test her theory, Evie took a sample of 25 students at her school, and she found that 5 were vegetarian. To see how likely a sample like this was to happen by random chance alone, Evie performed a simulation. She simulated 40 samples of size 25 from a larger population where 6% of the students were vegetarians in each sample. Here are the sample proportions for her simulated samples. Is given in this null distribution, or this dot plot. Now, to conduct our hypothesis test, let's go through the steps together. First, let's write the correct null and alternative hypotheses. Now here we're talking about the proportion of students that are vegetarian. So our null hypothesis is going to be a statement about P, the proportion of vegetarians. And you want to remember your null hypothesis is always a statement of equality, that it's equal to whatever the current belief is. And that came from our article that Evie read, that it said that 6% of teenagers were vegetarian. So our null hypothesis is going to be that the proportion is equal to 0.06. Always write this as a decimal. Now, our alternative hypothesis, this is going to be a statement about what Evie wants to find evidence to support. And you want to remember the alternative hypothesis always has either a less than symbol, a greater than symbol, or a not equal symbol. And you're going to determine which inequality is used in the alternative hypothesis based on the wording of what Evie believes. Here we're told that she thinks it's higher for students at her school. And if you're higher, then you're greater than 6%. So our null hypothesis, our alternative hypothesis, is going to be greater than 0.06. Now the fact that it's greater than 0.06, this also tells us that we're looking at a right-tailed test. We're going to use this when calculating our p-value. Let's move on. Next, we're asked to find what is our p-hat, our sample proportion. And remember, our p-hat always comes from a sample. Now in this problem, we were told that Evie took a sample of 25 students. And from those 25 students, 5 of them were vegetarian. This gives us a p-hat, or a sample proportion, of 0.20. Now notice this 0.0 or this 0.20 is greater than 6%. This does offer some support that more than 6% of the students at her school are vegetarian. But the question we have to ask is this larger by sampling variability, Or is it actually statistically significant evidence that it's greater than 6% in her school? To find out, we will find our p-value. Now you want to remember our p-value, nope, not p-hat, our p-value is always offering support for the alternative hypothesis. It's always going to be a value that's as likely as your sample proportion or more likely to favor your alternative hypothesis. So here, our sample proportion was 0.20. That's here. And we want to find values that are as supportive or more supportive for the alternative hypothesis. And those are values that are greater than. It's because we're looking at a right-tailed test. These are always going to be values that are more supportive, which are these values here. These three simulations offer support for the alternative hypothesis. They are as supportive or more supportive than our sample proportion. So our p-value is going to be those three values, those three simulations out of the total 40 samples in our simulation. Remember, these 40 represent the 40 dots. So our p-value is going to be the 3 divided by 40, or the 0.075. Now, we use the level of significance in this problem of 0.01. And we compare the p-value we calculated to our level of significance. And what we want to notice is that our p-value, which is 0.075, and we compare that to our alpha, 0.01, and we notice that our p-value is greater than our level of significance. Because it's greater than our level of significance, this tells us that we fail to reject the null hypothesis. Now we don't stop here. We need to give our conclusion in context of Evie's claim. So what we'll say is there is insufficient evidence that more than 6% of teenagers at Evie's school are vegetarian. Remember, when we fail to reject the null hypothesis, we say that there is insufficient evidence of the alternative hypothesis, which in this case is there's insufficient evidence that more than 6% are vegetarian at Evie's school. Let's look at another example. This might be a good place for you to pause the video and look through this next example on your own before we work on it together to see how you're absorbing this information. So I'd encourage you to pause it and take a look at it, and then afterwards come back and we'll look at it together. Okay class, I paused my video. I hope you did too and you worked through this. Let's go ahead and look at it together now to see how we can do on this example. The literature for a particular physical therapy says there is a 70% chance of success. Now here, notice what they're trying to give us is the null hypothesis. However, an online review says that one therapist has a lower proportion of his clients that experience success. Here, notice that they're trying to give us the alternative hypothesis about one therapist having a lower proportion. In a random sample of 60 of his clients, 31 experienced success. Notice here they're trying to talk about the results of a sample. They're trying to give us information about p hat, your sample proportion. Use the results of the 75 simulations shown in the null distribution to evaluate this claim. And here when they say the 75 simulations, note that they're trying to say there are 75 dots shown in this null distribution. Let's see if we can walk through this hypothesis test together. Let's start by writing the correct null and alternative hypothesis. First, the null hypothesis. Remember, we're talking about the proportion of people that experience success for this procedure. And it always has an equal sign, and it's equal to whatever the current belief is. Now, in this example, we were told that this comes from literature. And the literature says that it has a 70% chance of success. So that's what our null hypothesis is going to be. Again, write this as a decimal. Now, our alternative hypothesis. This is where we have to determine, do we use a less than symbol, a greater than symbol, or a not equal symbol? It's always going to be one of these three, and we have to be able to get that from the information in the problem. And it comes from what the researcher is trying to find evidence to support. Here we were told that the online review states that one therapist has a lower proportion that have success. And this lower proportion is what tells us about the alternative hypothesis. This is also telling us that we're looking at a left-tailed test. This is always going to agree with the direction of the inequality being less than. So to the left, less than. Now we go look for our p hat, our sample proportion. And remember, p hat always comes from a sample. So here, our p hat, we look at our sample. We were told that out of 60 clients, 31 experienced success. That's our p hat. Which gives us a decimal. I'm going to go to 2 decimal places, 0.52. Now again, notice that 0.52 is less than 0.70. This does offer some support that less than 70% are experiencing success. But again, we want to be skeptical. Is this 0.52 less than 0.70 by sampling variability, or does it actually offer statistical support that less than 70% are experiencing success? To determine this, we will compute our p-value. Now, to find the p-value, we first locate p hat in our null distribution, the 0.52. And 0.52 is going to be about right here, less than 0.53. And we're looking at a left-tailed test. We're looking for values that support the alternative hypothesis of being less than 0.70. We're looking for values that are as supportive as that 0.52 or more supportive. meaning we calculate or count how many simulations less than 5.52 are in the null distribution. And here we notice that there are only 2 simulations that are as supportive or more supportive of the alternative hypothesis. So our p-value, it's going to be those 2 simulations out of the 75 that are offering support for the alternative hypothesis, which is 0.03. Now, what do we do from here? Well, we grab our p-value and we compare it to our level of significance alpha. Here our p-value is 0.03 and alpha is given as 0.05. And we notice that our p-value is less than alpha. Now remember my short line. If your p is low, your null must go. Here our p-value is less than our level of significance. So what this tells us is we are going to reject the null hypothesis. But we can't stop there. We need to give our conclusion in context of the therapist's claim. So what this means is there is sufficient evidence that a lower proportion, make sure we include the proportion, that a lower proportion of clients experience success. And again, let me emphasize a couple of points here. When we reject the null hypothesis, there is sufficient evidence of what your alternative hypothesis was saying. That is, that there is a lower proportion of clients that are experiencing success than was currently believed. All right, let's look at one more example. And again, this might be a great place for you to pause the video for a minute and look through this example on your own before we do it together, just to see how you're absorbing the information. So I hope you'll pause the video. I'm going to pause mine as well. Okay, class, let's see how we're doing. I hope you pause the video and work through this on your own first, but let's see how we're doing. I'm going to read through the problem and try and identify important pieces of information as we go. It is typically recommended that people eat breakfast in the mornings. However, trends show that at a local school, 10% of students still do not eat breakfast. A dietitian claims she can change the proportion of students that eat breakfast in the morning. So she gives a seminar to the students. After the seminar, 3 out of 70 still do not eat breakfast. Does this provide strong evidence that the dietitian changes the proportion of students that eat breakfast in the morning? Now again, there's a lot of information here. Let's see if we can identify what was important. First, let's write the null hypothesis. The null hypothesis is supposed to be a statement about your parameter P, the proportion of students that eat breakfast. And we were told that trends are saying that this is 10%. This is our null hypothesis. Remember, your null hypothesis always has an equals. Now the alternative hypothesis. This comes from the claim. Our dietitian claims she can change the proportion. Now remember, our alternative hypothesis always has either a less than, a greater than, or not equal symbol. And what we want to notice is that the word change does different by being less than, or you can be different by being greater than. And that's what tells us that our alternative hypothesis is not equal to 0.10. This is also telling us that we're looking at a two-tailed test. We're going to need to use this when we're calculating our p-value. Now below is the dot plot for 100 simulations. Now remember that 100 simulations is telling us there is 100 dots here. This is going to be different generally in all problems. And the ones we did earlier, there was 40 simulations or 75 simulations. So make sure you look for this wording. This simulation represents the number of students that eat breakfast out of 70, assuming the null hypothesis is true. Now the first step to finding the p-value is to find the proportion of dots that represent 3 or fewer students eating breakfast. Now if we're looking at our scale here, 3 or fewer would be this group. And I'm calculating 9 students, or 9 times was 3 or fewer not eating breakfast. And this was out of the 70 simulations, which gives us a value of 0.13. Now this is not our p-value, because you want to remember in this problem we were testing if the proportion is different than 0.10, and that was telling us we were looking at a two-tailed test. And when calculating the p-value for a two-tailed test, you have to look at extremes in both directions. Now one way we can calculate this p-value for a two-sided test is to multiply our answer by 2. This is a great shortcut for calculating your p-value on a two-sided test. You calculate the proportion on one side and then you multiply by 2. So here our p-value is going to be the 0.13 times 2, which is 0.26. That's our p-value. Now here we're told to assume that our level of significance is 0.10. So again, what we'll do is we'll take our p-value, which was the 0.26, we'll compare it to the alpha that was 0.10, and notice that our p-value is greater than alpha. This tells us we will fail to reject the null hypothesis. Now remember, don't stop here. We need to give our conclusion in context of the hypothesis test, in context of what the alternative hypothesis was saying. So what this tells us is there is insufficient evidence if I could spell evidence, that would help. Evidence that the proportion of students that eat breakfast is different than 10%. Now remember to notice the wording here. If you fail to reject, then you have insufficient evidence of what the alternative hypothesis was saying. In this case, there's insufficient evidence that the proportion of students that eat breakfast is different than 10%. Okay, I hope this video and this supplemental notes are helpful for you when you're completing your homework. However, if you have any questions after looking through this and looking at your homework, definitely reach out to me. I'm happy to help. Hope to see you guys next Tuesday during our next virtual office hour. Talk to you later.